In this video, we will discuss double and half angle identities and notes and homework. So looking at our first question, we are told that if cosine of theta is 8 over 17 and theta is between 3 pi over 2 and 2 pi, for us to find sine of 2 theta. So the first thing that we need to do is write out what sine of 2 theta might look like, and this is going to be one of our formulas that we're given. So if we go back and look at the top of our sheet, we see that sine of 2 theta is going to be 2 sine theta cosine theta. Now from that, notice that we know cosine theta is 8 over 17. So this is where we need to build us a right triangle. Well, that looks pitiful. Let's see if we can do a little bit better there. Somewhat better. And a right triangle. And I'm going to put theta up here. Now cosine, remember, is going to be adjacent over hypotenuse. And so I'm able to label my sides adjacent and then hypotenuse. And so we see that 8 squared plus this missing side squared equals 17 squared. And if we work this out, we're going to get that side that we're missing to be 15. And so now we're ready to fill in what sine of theta should be and cosine of theta should be. So here's sine of 2 theta is going to be 2 times sine of theta. We're going to come back to this triangle, and that's going to be 15 over 17 times cosine, which we saw in our problem we were given is going to be 8 over 17. Now we have to look to see, well, what's positive, what's negative. We're between 3 pi over 2 and 2 pi. And remember, all students take calculus. And so remember, cosine's positive down here, but sine is not. So we need to make sine negative there. And so now we just find this product. And once we multiply that out, we're going to have negative 240 over 289. And yes, please use a calculator here. Alright, so for number 2, working out very similar, same thing here. So we're told that sine is going to be negative 1/3. We're between pi and 3 pi over 2, and we need to find tangent of 2 theta. So let's write out that we know tangent of 2 theta. This is one of our formulas. It's going to be 2 tangent theta over 1 minus tangent squared theta. Okay, and so let's take what we know about sine of theta. We can build us a triangle. And we can put our theta up here. And sine, we're going to have 1. Opposite is 1. Hypotenuse is 3. And so notice that we're going to have 1 squared plus a missing side squared equals 3 squared. And so a squared is going to be 8. So a is 2 root 2. So we've got that missing side is 2 root 2. All right, so we're now ready to come back over here. Tangent to theta is going to be equal to 2 times, well, tangent theta. Remember, tangent is going to be opposite over adjacent. So that's going to be 1 over 2 root 2 over 1 minus, and then tangent squared, so that's going to be 1 over 2 root 2 all squared. Now keep in mind that you should be able to go through and do some canceling here. So this 2 and this 2 are going to cancel. So that's going to be 1 over the square root of 2 over 1 minus, and this is going to be 1 over, well, 2 squared is 4 times, and that root 2 squared is just 2, so that's going to be over 1 minus 1/8. All right, and so, goodness, let's go ahead and use our calculator sum. We have 1 over root 2 over 1 minus an 1/8. That's going to be 7 over 8. And then from there, you've got your keep, change, flip. So we're going to keep 1 over root 2, change our division and multiplication, and flip, so I have 8 over 7. So that final answer is going to be 8 over 7 root 2, and you can leave it like that. For our next problem here, we need to find cosine of 2 theta, and notice that we have several different things that we can use for cosine of 2 theta. And it's just going to depend on what we're given. So let's see what we can use for this one. Let's go ahead and see if we're given tangent of theta, then let's go ahead and draw out our triangle. And it looks like, again, we can put theta up at the top. And so with this, then we know tangent is going to be opposite over adjacent. And let's see, our sine is going to be negative because we are in, let's see, what quadrant are we in? We're going to be in the second quadrant, it looks like, from pi over 2 to pi. All right, so that's why tangent is negative. Let's go ahead and see for cosine of 2 theta, which one do we want to use? It looks like it might be easier to just use the 2 cosine theta minus 2 cosine squared theta minus 1. That way we don't have to really jump out into too many more of our trig functions. And so let's see. With that one, then let's go ahead and find our missing side. We have 5 squared plus square root of 7 squared equals our hypotenuse squared. And if we go through and find our missing side here, goodness, that's going to be 35, or 35 nothing. That's going to be 25 plus 7 equals hypotenuse squared. So that's going to be the square root of 32. And the square root of 32, that's going to be 2 or let's see, 32, no, 16. So that's going to be 4 on the square root of 2. That's going to be our hypotenuse. Okay, so now let's go through and see what our 2 cosine squared theta minus 1. So let's go ahead and plug that in. So I know that cosine of 2 theta is equal to 2 cosine squared. So cosine is going to be 5 over 4 root 2 all squared minus 1. So that's going to be 2 times 25 over 16 times 2, and then minus 1. And so let's see, that 2 can cancel with the 2 out here. And so that's 25 over 16 minus, and that's going to be 16 over 16, subtracting fractions. And so 25 minus 16. So we're going to have 9 over 16. All right. Okay, now we're going to talk about our half angle identity. And big note here, to determine the sine, you're going to have to look at what quadrant you're going to be in, and that's going to help you. So do keep that in mind. So for the first one here, find the exact value of each expression using the half angle identity. So all of those identities that you first had, those are all going to be here. So again, good thing to keep in front of you or on your unit circle. So for 67.5, that's the same thing as saying that is cosine of 135 divided by 2. Now, keep in mind at 67.5, that is in quadrant 1, and cosine of a quadrant 1 angle is positive. So, when we go to plug that in, keep in mind that it's going to be cosine of that angle. Using your formula, keep in mind the formula says cosine of theta over 2, which is what I have right here, theta over 2, is equal to plus or minus, which this is going to be positive because it's quadrant 1, plus or minus 1 plus cosine theta. Notice it's just talking about theta now, all over 2. So in this case, we're going to be talking about from right here, that's going to talk about cosine of 135 degrees. That's what that's talking about. So when we plug this in, that's positive square root of 1 plus cosine of 135, and that's all over 2. And so that's going to break down to be the square root of 1 plus cosine of 135 is root 2 over 2, and all of that's over 2. And every bit of that's under that radical. All right, and so really that's a mess there. You can multiply top and bottom by 2. We could leave it, yeah. Let's multiply the top and bottom by 2 since that's a denominator, and just clear up one of those denominators. So your final answer, and distribute this, so it's going to be 2 plus, When I multiply it here, those 2's are going to cancel, so you're going to be left with root 2. And then all of that is going to be over 4. And let that be your final answer. Okay, our next problem, tangent of 157.5. So we're going to rewrite that, and that is going to become tangent of 315 over 2. And so looking at our quadrant, this is going to be in quadrant 2. So tangent in quadrant 2, that's going to be negative, so we're going to have to watch our signs. And so tangent 315 over 2, looking at our identities, which one might be a little bit easier for us to work with, I would use tangent theta. I like the one that has just sine theta. Just seems to be a little bit easier to work with over 1 plus cosine theta. But that's not always the best one to go to, but sometimes it works out better. So for this one, then that means I'm going to have sine of 315 over 1 plus cosine of 315. And now I substitute in my known values. Sine of 315, that's negative root 2 over 2 over 1 plus sine or cosine, that's going to be just root 2 over 2. And to reduce this down a little bit, let's multiply the top and bottom by 2 to get rid of some of the fractions. And so the 2's are going to cancel here on the top. So this 2 and this 2 will cancel. So I get negative root 2 over. And here distribute this, so I'm going to get 2 plus root 2. And we can stop there and let that be our answer. Okay, this next one looks a little trickier than what we're kind of used to. In this one, we're going to use our fraction. And really, we're going to think about this one, and it's really more or less going to be in a different quadrant. Let's write it out, and then you'll see before I do that quadrant first. That might confuse us. So what we're going to have here, let's just rewrite this. This would be the same thing as having sine of 11 pi over 6, and then that's all over 2, or divided by 2. So that's going to change a little bit. That's going to be 11 pi over 12, but it looks different. And so for sine, using our formula, remember that the sine formula, or go get it off of where the formulas are, you're going to have the square root of 1 minus cosine theta all over 2. So for this one then, it's going to be the square root of 1 minus cosine of 11 pi over 6, and then that's all over 2. So here, you're going to get the square root, if my pen will freaking write. Okay, you're going to get the square root of 1 minus, and then here cosine of 11 pi over 6, that's going to be the square root of 3 over 2. And then all of this is over 2 and still under that radical. Okay, and so this one here looks a little strange, but we can still fix it. I would still multiply top and bottom by 2 over 2 under that radical. And so that's going to put you at 2 minus root 3 all over 4 under the radical. And that's going to be it. Okay, looking at our next one. Right, so we need to find sine of theta over 2. So let's write out, what does sine of theta over 2 look like? Well, that's going to be square root, and that's going to be 1 minus cosine theta all over 2. And so then sine of theta over 2 is going to be equal to the square root of 1 minus a negative 3/8, so plus 3 over 8 all over 2. And again, you can multiply everything. The common denominator here would be 8 over 8 if you wanted to. And that's going to be the square root of 8 plus 3 all over 16. And so that can be the square root of 11 over 16. Or you can even reduce that further if you wanted to. You can make that square root of 11 over 4 if you wanted. Okay, number 8. Very similar to the same thing that we did earlier. I would look to see, what does tangent of theta over 2 look like. And so tangent of theta over 2 got a couple of things you could dig through. You've got sine here, so you might want to find the one that had sine in it. And so you have sine theta over 1 plus cosine theta. Or you could use one of the other ones. Either one's going to be fine. So, if you know 12 over 13, this is going to be a 5, 12, 13 triangle, because you already know this much of it. And so, what quadrant you're in? Well, it looks like you're going to be in the 4th quadrant. And now you can go ahead and fill in tangent of theta over 2. Sine of theta is negative 12 over 13 over 1 plus, and so cosine is going to be 5 over 13. And so you can reduce that down. So you've got negative 12 over 13. And then the bottom 1 plus 5 over 13, that's going to give you 18 over 13. And of course the 13s would cancel. And so you have negative 12 over 18, and that's going to be a negative 2/3. And even if you chose a different identity up here, you should still get negative 2/3 for your answer. Okay, so let's find out cosine of theta over 2, what that looks like. So, finding our formula for that, you're going to have the square root, and that's going to be 1 plus cosine theta all over 2. Will be the start of that. And so now looking at what pieces you have, you need to go through and try to find your right triangle. Now keep in mind you can always put that tangent is over 1. So if you draw your triangle, you've got, pencil's not working. Let's get it working. There we go. So there's my theta. And you've got 4 root 3 adjacent, or nope, goodness, need opposite. So 4 root 3, opposite and adjacent's 1. So we have 4 root 3 squared plus 1 squared equals your hypotenuse squared. So that's going to be 16 times 3 plus 1. So 48 and 1, so 49 equals hypotenuse squared. So your hypotenuse is 7. So now we have everything we need to fill this in. So we're going to have the square root of 1 plus cosine is going to be 1/7 over 2. So then that's going to be the square root of so 1 plus 1 over 7, that's going to give me 8 over 7. And that's all over 2. And so here we're going to have 8 over 7 times 1/2. Those are going to cancel. So I'm going to be left with the square root of 4/7. Alright, and so that is going to finish up your notes part. We do need to see where we're going to be at. We are in the third quadrant, aren't we? So third quadrant, that one's actually going to be negative this time. Alright, homework will be coming up on the next video.